Hello everyone, welcome to another particular lecture. So in this particular lecture we are actually continuing our previous lecture, that is the naming of chiral compound. So in the previous lecture we are discussing about that the DL nomenclature, CIP rule and the RS nomenclature in the Fisher configurations. So if you are missed and directly come to this particular lecture, then I will highly suggest to go through the previous lecture, and then after completing this particular lecture then you come here, because here in this particular lecture we are actually advancing what we have studied in the previous lectures. Okay, so first we are discussing about the RS nomenclature determination for the flying wedge projection. We are actually discussing about that if the compound is given in the Fisher projection, then how can we determine the RS configuration. But if it is given in the flying wedge manner, so if you are going or if you are convert the flying wedge to Fisher projection, there will be two difficulties. First, there is a high chance of getting incorrect Fisher projection first, and the second thing is during competitive exam you don't have this much of time to convert flying wedge to RS nomenclature, and then you will determine the particular absolute configuration of the chiral center. And if you are going to do this, then I don't know that you will complete all the question in the particular competitive exam. So we have to know that how can we determine the absolute configuration of the chiral center from the flying wedge itself. And for determining absolute configuration we use 4b plus rule, that is given by eliel. Okay, so first of all, the very basics we have to clear that the group which is present in the wedge bond, that is called a front bond, and group present in the dash bond, that is the below the observer, that is called a back bond. Okay, and also from this the all group are assigned the priority order according to CIP rule, and the CIP rule we discussed in the previous lecture. So first check the particular lectures to understand what is the CIP rule is. So after taking the priority order, you have to leave the dash bond group and check the rotation of other group based on priority. Okay, so little bit confusing, but don't worry. Now the 4b plus rule says that 4b plus 3b minus 2b plus 1b minus, okay, that the b is suggest the back bond or the group that is present in the back bond, where B is a dash bond group, and number. This particular number 4, 3, 2, 1 is determine the priority, like what is the priority number of the dash bond group. Okay, and the plus sign signifies that if the clockwise rotation apart from the particular group that is present in the dash group, if the other groups having the clockwise rotation, then it will be R, and if it will be the anti-clockwise, then go for S. And the minus signifies that if it is clockwise rotation, then it will be S, and anti-clockwise it will be R. So till now I know it is very much confusing. I think you will be blown out with the concept, but when we are talking about the simple example, then it will be everything clear. Okay, so now let us understand the 4b rule with an example. So here in this particular compound that is present in the flying wedge representation, first we have to determine the priority order. That is the most important work. Okay, so here already OH have the highest mass, oxygen, so it will be priority order 1. Between CH3 and pH it will be a 2. CH3 will be a 3 priority, and the hydrogen is the 4th priority group. Okay, so the priority order should be like this. Now we have to check that which particular group is present in the dash bond. So there it is a dash bond, that is alternatively called the back bond. Okay, this particular back bond contains hydrogen. Okay, and what is the priority of this particular group? It is a 4th priority group. That means 4b plus rule was applied. In previous, here this type of rules are applied. Now since the priority of the back bonded group is 4, then the rule applied is 4b plus. Now we have to check the rotation of all other molecules except the particular group that contains or that present in the dash bond or the back bond. Okay, so here 1, 2, 3, if we check about the rotation value, so 1, 2, 3 is clockwise in nature, and the mnemonic given here the positive. Since it is positive, that means the clockwise rotation and it leads to the overall configuration of the particular molecule is R. As simple as that. If you are still confused, then rewind this particular video and understand. And if you are somewhat understand, then I will show you another example to crucify this particular concept into you. Okay, so in this particular we have taken another example. Okay, so here this particular group is there. Now interestingly, if we look about the priority order, so obviously this will be the first priority, the pH will be the second priority, and here the ethyl molecule getting the third priority over methyl group. Okay, so the priority order is something like this. Now what is the dash bond? Dash bond contained group is ethyl, which is the 3 priority. So which the rule is applies 3b minus. So here the priority of this particular dash bonded group is determined that which rule is applied. So here the 3b minus rule is applied here. 3b minus applied. So now we have to check the rotation of 1, 2 and 4. So the rotation that will be observed now, that is a 1 to 2 to 4. Since this particular 3 group is present in the dash bond, so we just eliminate this particular group. Now if we look about the rotation 1 to 4, that is a clockwise rotation, but here the rule applied is 3b minus. Now the minus which suggests the opposite, like clockwise means S will be the absolute configuration of this particular chiral center. So that means the configuration of the molecule is S. I hope it will be cleared. Okay, so now we will move to the some advanced thing, that is a small r and smallest nomenclature. But before understanding the small r and smallest nomenclature, you should have to understand that what is the pseudo-asymmetric center. A pseudo-asymmetric center is a stereo center in a molecule where two substituents are identical in connectivity but different in spatial arrangement. So the pseudo-asymmetric center is a stereo center of a molecule where two substituents are identical in connectivity but different in spatial arrangements. Okay, due to the presence of either other chiral center in the molecule. Just take the simple example here. So these two groups are identical, but the groups are different in the configuration. Like this particular chiral center having the R configuration and this will be the S configuration. So there is a small exercise for you. Just determine the priority order and validate that this is the either R or S or not. Okay, so this is a small exercise for you. Okay, so these two groups are identical, we can say, but the absolute configuration of these two chiral center are different. That means this particular center becomes a pseudo-asymmetric center. But here the both groups are identical in terms of groups, but these two are also chiral center have the same configuration. That means this particular are not a pseudo-asymmetric center. And how to name the pseudo-asymmetric centers? The pseudo-asymmetric center are designated using the notation of small r and small s instead of capital R and capital S. Okay, and this designation acknowledges the relative configuration rather than absolute stereochemistry. That you have to understand that this smaller and smallest nomenclature is at the relative configuration, not the absolute one. Okay, so how let us determine how to determine the RS nomenclature of the pseudo-asymmetric center. Same CIP rule is applied for priority assign, but here we are applying the third rule of CIP, that is the R configuration is getting more priority than S configuration. Okay, so here in this particular group we can say that this OH will be definitely 1 because of the highest mass. Then this particular chiral center or this particular carbon having the R configuration, that is will be getting the most greater priority than S configuration, so it will be on 2. Okay, and this will be the 3, and this particular will be the 4 hydrogen. Now the rule says that if the order from 1 to 3 clockwise, then configuration is S, small s. Why small s? Because the H is the present in the horizontal bond. Since it is the present in the horizontal bond, that means that mnemonic rule is not applied. So that means the 1, 2, 3 is clockwise, then configuration is small s, and if the rotation is the anti-clockwise, then the configuration is R. So here 1, 2, 3, the anti-clockwise rotation, that means this particular center, the pseudo-asymmetric center contains R configurations. Okay, now we are talking about the EZ nomenclature. EZ nomenclature used for diastereomers. Priority you have to assign for the both carbon center itself. Now if highest priority group at the same direction, there is a cis. The remember technique is cis. You can imagine the cis equal to cis. Okay, and if highest priority or a group in the opposite direction, then it will be called trans. Just take a simple example of Stillman here. Okay, so we are talking about the individual carbon center first. Now for this particular carbon center, between these two groups, this phenyl group has the highest priority over this particular group. Okay, and in this particular carbon center, obviously the phenyl group getting the highest priority, then this particular hydrogen group. Now here you can find that two priority groups, the two highest priority groups are in the same direction. That means this is the Z, or we can say cis compound. And here the priority group, this will be the 1 and this will be the 1. This one in terms of this carbon, and this one is represented this carbon in terms of this carbon. Okay, so they are two are different in direction. That means this is the trans geometry. This is the simplest EZ nomenclature. Now we are talking about the Threo and Erythro configuration. Is the Threo and Erythro configuration suggest, like when a compound that contains two chiral centers is drawn in a conventional Fisher projection formula, that is RCCR, or a root chain is written vertically, and at least two similar type of groups in terms of electronegativity present on the same side of the Fisher projection formula, then the compound is called erythro. And if the two similar type of groups present in the opposite side of the Fisher projection, then it is called threo. Now what is written in this particular line, just we have to understand. First erase this, all those things. Now here first the root chain is similar to the DL nomenclature. The root chain is considered where the most oxidized group present in the highest top of the vertical bond. This is the root chain. Now here this between these two particular group, this OH and OH group are similar, or here it is the same, but if it is the NH2 group was there instead of OH, then we can say that these two groups OH and NH2 are similar in terms of electronegativity. Now if these two are the same side, either right or either left, then it is called erythroisomer. And if the both are present in the opposite direction, means one similar kind of group is present in the left direction and one is similar group is the right direction, then it called as a threoisomers. Okay, and now there is another thing, the Pref-Parf configuration. Actually this is not come in the comparative exam, but for the knowledge purpose you can understand. Like after imposing priority of this particular group, if all the chiral center are clockwise or anti-clockwise, then it is called Parf. Like here in this particular group, see 1, 2 and 3 priority group is there, so the rotation is the clockwise anti-clockwise rotation. Similarly this also rotate anti-clockwise, so both the chiral center has rotated anti-clockwise rotation. That means it is called Parf, that is a priority anti-reflective. But if one is anti-clockwise and one is clockwise, then it is called a Pref, priority reflective. Here you can see that this particular chiral carbon, the rotation of this particular chiral center is anti-clockwise, whereas this particular center is rotated clockwise. So that means it is called a Pref configuration, that is priority reflective. So now we're talking about some interesting thing about stereochemical phases. Now phases of carbonyl compound are differentiated by using Re-C nomenclature, not RS nomenclature. So similarly it also contains same rule, the priority based on the CIP rule, between these three center, we have to check priority. Now if 1 2 3 is clockwise, then configuration is re, and if 1 2 3 is anti-clockwise, then the configuration is C. Okay, so here in this particular group, 1 is the obviously the carbonyl oxygen, 2 is the phenyl group, and 3 is the hydrogen group. Now the rotation is anti-clockwise, that means this particular phase is C phase. That means if any nucleophile attack from this particular site, means the top of the site, then we can say that the nucleophile attack in the C phase of this particular carbonyl compound. Now this thing will be very much important, like if this particular group is the C phase, then its mirror image, or from the back side, if we view, like if we view from this particular side, then it is look as a C phase. But if we view from the back side of the particular molecule, then the phase will be re. Okay, like if one phase is re, then the opposite or mirror phase is C, and vice versa. So that means if any nucleophile attack from the backhand side of this particular carbonyl compound, then we can say that the nucleophile attack in the re phase attack. And this particular stereochemical phase is very very important when we are talking about the asymmetric synthesis. And this type of, you have to understand very clearly that what is the re phase attack, what is the C phase attack. Now if the pH group is here, like in this particular base, this will be the re phase. If we view from this particular center, this will be the re phase, and from the opposite case, if we view, then it will be projected as a C phase of the carbonyl center. Okay, so this particular stereochemical phase is very very important, not right now, but when you are talking about the asymmetric synthesis, especially the stereochemical models, that is very important in this particular case. Okay, so with this we have to end this particular class. So in this particular class we have learned that how to determine the RS nomenclature for the flying wedge projection. Then we are talking about the smallest nomenclature, that is the determination of configuration in pseudo-asymmetric center. Then we are talking about the Threo erythro isomer, Pref-Parf, and stereochemical phase.